Hi guys, welcome back to the channel. So this is not so straightforward problem and it requires some decent level of concept and tricks to solve it. So today let's give you a solid set of concept through this problem which will help you in doing much better in IIT JEE or Olympiads or any other engineering examinations. We will also give you some tips and steps along the way to solve these kind of problems in general manner. Now, if you wish to give it a try, then you can pause the video and try it out. But let me first explain what's going on. So there is a board which is lying on top of two cylinders, and these cylinders are rolling down. And we need to figure out the acceleration for the board. Now, you can assume that there are enough frictions everywhere to ensure that pure rolling is happening. That's it. So we need to find the acceleration for the board. So go ahead, pause the video and try to solve it. Okay, if you have solved it, congratulations. Also, for everyone, please feel free to send the questions or queries and we would love to respond back as soon as possible. Before we start solving this problem, let me first give you some basic steps that we follow to solve any of these kind of problems. And they are pretty basic steps. So steps. So number one step is understand the problem properly. So understand what's going on. This is very, very important. And use your logical analysis to understand the problem. Second thing is draw the FBD diagram. And the last one is write the equations. If you do these three things, your problem is more or less already solved. And after that, all you need to do is to solve the simultaneous equations to get to the answer. But let me first give you some concepts here. The first thing we need to understand is what is the meaning of pure rolling? And let's assume that it's rolling on horizontal surface. It can be any surface. This could be sphere also. But let's say this is rolling on the horizontal surface with angular velocity omega. And let's say the linear velocity is v. The meaning of pure rolling is that there is no slipping happening at this point of contact. Hence, we can assume that the velocity of the point of contact is zero. Because if there is any velocity of the point of contact, then this cylinder will slip over this surface. But since it is pure rolling, so it's not slipping. How do we get it using mathematics? Since the entire cylinder is moving with velocity v, so this point is also moving with velocity v. Correct? Now, because of omega r, this point also has a velocity in this direction, which is omega r. Let's assume that the radius is r. And if the p is not slipping, so velocity of p is 0. That means v minus omega r is 0. That means v equal to omega r. Right? And if you differentiate this, then this becomes a equal to alpha r. Okay? Because a is nothing but dv by dt. And alpha is equal to dw by dt if we differentiate with respect to time. Now, what is the velocity of center? So let's say this is point P. It has velocity 0. But what about center? Center, as we know, we have already said that its velocity is v, which is equal to omega r. And what about the topmost point, let's say Q? Now here it has a velocity v because the entire cylinder is moving with v, plus omega r is adding in the same direction. So v plus omega r. And omega r is nothing but v. So this one has a velocity 2v. Right? So this is the anatomy of pure rolling. If object is pure rolling, then you can understand the velocity of any given point on that object using this concept. So right now, I just considered 3 points here, P, Q, and C in this line, but you can take this arbitrary point and also you can get the velocity of that point in any direction as you like. So now if this is understood, then let's understand what's happening here. Let's say that these cylinders are rolling down with acceleration A. So which means that, or let's say the velocity here is omega and the linear velocity is v. So the velocity at this point is going to be 0. This is v and this is going to be 2v, correct? So let's say 2v. Now the same thing, if the acceleration of cylinder is a, then at this point the acceleration is 2a. Now it is given that the board is also not slipping, which means that the velocity of this point for cylinder and board both are equal. If they are different, the board will start slipping. So which means that the board's acceleration is 2a. It's as simple as that. Now this is the basic trick here. If you understand this, the problem is more or less solved. Now today we are going to solve this problem using two different methods. Okay, and this will give you a very good understanding about how to tackle such problems. So one method is definitely energy conservation, and the other method is we will use the typical, our Newton's law. Okay, we'll use F force and torque. Okay, so I assume that we have understood the problem. Now let's draw the FBD. So let's draw the FBD for the cylinder first. So let's take this cylinder. Okay, the weight is acting downwards. Assume that there is a friction here, F1, and here also because of the board there is another friction, F2. We can also take, let's say, N1 is the normal reaction from the wedge and N2 is from the board. And let's say this is going with acceleration A. Now let's also define the axis. So let's say this is x-axis and this is y-axis. This angle is theta. Therefore this is theta. This is 90 minus theta and this is theta, right? This will help us writing the equation. Now let's write the equation. For Fx, sum of force vector equal to mass into acceleration and sum of that. So we'll write in x direction. So this is m by 2g, by the way. So this is m by 2g sine theta in x direction. F2 is also in positive x and F1 is in negative x, equal to m by 2a. Let's call this equation 1. Now using torque at C, let's say this is C, equal to I alpha. So you see F1 and F2 both are causing torque in this direction. So we can take F1 plus F2 into R. Let's say R is the radius for the cylinder, should be equal to I is nothing but half m by 2 R square alpha, right? So F1 plus F2 is equal to m by 4 alpha R and m by 4 A, because A is nothing but alpha R, right? Let's call this equation 2. Let's draw the free body diagram for board also. Let's say this is our board and the weight is acting downwards and this is moving with 2A. We just discovered that. And there is a force F2 here from the cylinder 1 and then another F2 from cylinder 2. Similarly, N1 and N2 will be 2 times. Sorry, N1 will be 2 times. Okay. So we again write the same, fx equal to max, and this time it is mg sine theta minus 2f2, okay, and m into 2a, right? We know that the acceleration of the board is 2a. Let's say this is 3. Okay. So from here we get f2, right? And if we put this f2 in 2, then we'll get f1. So from 2 and 3, we get f1 equal to ma by 4 plus ma minus mg by 2 sine theta, hence f1 is 5 ma by 4 minus mg by 2 sine theta. Let's say this is fourth equation. And now using f2 and f1 from here, we'll put it in the first equation, f2 and f1, and we'll get the acceleration. So let's do that. So it is, the first equation is m by 2 g sine theta plus f2. f2, if you see, is nothing but m by 2 g sine theta minus ma and minus f1. So f1 is here. So f1 is minus 5 ma by 4 and minus minus plus, so mg by 2 sine theta. This is equal to ma by 2. Now you see mg sine theta by 2 is there 3 times. So this is 3 mg sine theta by 2 and equal to ma. If you take common, then 1 plus 1 by 2 plus 5 by 4, which is 11 by 4 ma. Therefore, a is equal to 6 by 11 g sine theta, and that means that acceleration of board is 2a equal to 12 by 11 g sine theta. And that is the answer. Okay, it's not that difficult. But now let's use the conservation of energy and let's see what happens here. So in the conservation of energy, we can assume that the loss in potential energy is equal to gain in kinetic energy of the system. So let's say that the cylinder goes down through distance x. So the board will go down with 2x. Using this, let's write the loss in P, and that is going to be m by 2 g x sine theta, because x is in this direction, so in vertical it will be x sine theta, and there are 2 cylinders, so we'll multiply it with 2, and then for board we have mg 2x sine theta, because it will go down with 2x, and that is equal to 3 mg x sine theta. Correct? Now let's say the kinetic energy. Kinetic energy is again 2 times, because there are 2 cylinders, half mv square, so half m by 2 v square, right, plus half m by 2 v square. This is half I omega square, I is half mr square, and v equal to omega r, so I'm directly using that, and plus the kinetic energy of the board, which is half m 2v square. and that is equal to mv square 1 by 2 plus 1 by 4 plus 2, which is mv square by 11 mv square by 4. And if p equal to k, then we have 3 mg x sine theta equal to 11 by 4 mv square, and therefore we have v square equal to 12 by 11 g x sine theta. Now acceleration is nothing but dv by dt, so let's differentiate with this respect to time. So 2v dv by dt equal to 12 by 11 g sine theta, because these are constant, and dx by dt. Dx by dt is nothing but is v, right? So v and v will cancel out, and hence dv by dt is a. So a will be 6 by 11 g sine theta. Therefore 2a will be 12 by 11 g sine theta. So the second approach is a lot more simpler, straightforward. But the first one is very important for us to understand, because in many cases, the energy will not be conserved and you will need to use the Newton's law. I hope you learned few things here. We are a team of ITNs, and we believe that building concepts through challenging problem solving is an excellent approach to help students excel in IIT JEE or even Olympiads or other engineering entrance examinations. So by subscribing to our channels, you can gain access to valuable insight, tips, and strategies that will enhance your learning experience and also boost your performance. Thank you very much.